Hi, welcome to Algebra 2 Common Core. Today we're going to take a look at finding exponential regression equations on our calculator. So first of all, you definitely need to have your graphing calculator in front of you. If you don't, please stop the video and go find your calculator and start it back up again. I'd like you to flip over to the back of your note sheet. So we're on page 20 today, and then we'll go back and do the examples together. So I want to go through the calculator instructions for how to do an exponential regression first. First and foremost, in statistical modeling, a regression is just a statistical process for estimating the relationship among variables. So since we have been working on exponential functions, we're going to be doing an exponential regression today. Back in Algebra 1, you did learn how to do linear regressions, but for Algebra 2, it's important that we know other higher level regressions, so today, exponential. Now, first of all, let's enter in the box in your notes on page 20, let's put down the steps that we need to do a regression on our calculator. I'll lead you through the steps. So step number 1 is just enter the data in lists 1 and list 2. Now to do that, we are going to start by going to our stat key. So I want you to locate the stat key on the face of your graphing calculator. It's located right here. When you press stat, you should see this window right here on your calculator. We are going to choose option number 1, which is edit. So I'm going to put a big arrow there and say, let's choose number 1, edit. When I choose number 1, I may see a table of values that looks like this. I want list 1 and list 2. Now, if your calculator already has numbers listed in list 1 and list 2, I am going to first of all have to clear those lists. So to clear the lists, use your arrow keys to arrow up to the top of list number 1. Highlight this top line where it says list 1. Press the clear key on your graphing calculator and then press the enter key. Never press the delete key at this point because delete will delete the list from your graphing calculator. There is of course a way to get it back, but let's just press clear. Same thing with list number 2. Arrow all the way up to the top of list 2, so this part is highlighted up here. And then go to your graphing calculator and press clear, and then press enter. Now, we're going to put numbers into those lists. So today, I'd like to pick some numbers that are easy for us to work with, and hopefully we'll recognize these numbers. So in list 1, I'm going to enter 0, then 1, 2, 3, and 4. So go ahead and enter those numbers with me. In list 2, I'm entering as my first answer 1, 3, 9, 27, 81. So this is just for practice with an exponential regression. Hopefully you recognize the exponential function that we're modeling right there. Now while you're working on your calculator, please still be filling in the steps on your note packet. So my next step, step number 2, is to again go back to the stat key on the front of our calculator. When I press the stat key, I again will get something that looks like this on my calculator. You'll see option 1 and 2 at the top, but I've actually wanted to focus on a lower option, so that's why I've scrolled down a little bit. Before I scroll down, I have to go to arrow and then calculate. So I'm going to use the arrow key on my calculator and highlight where it says calculate so that it gives me the calculate menu. Now I've got to get all the way to the end here. It's not quite the end because there are more values. I see that because there's an arrow here. And I want to choose option 0, which says exponential regression. So I've put that in my notes here. I want to say choose stat, calculate, then pick 0, exponential regression. Now, when I choose exponential regression, what's going to happen is I will get a screen where I'm going to enter where the numbers are on my graphing calculator. XList, I want to put in L1. To put in L1 on the front of my calculator, I'm using the second key and then the number 1 key, and you should see above that key the designation L1. Then for my Y list, I'm going to put in L2. I get that by saying second number 2. Now, if anything else has anything listed, like list 1 or list 2, go in and delete those values. So if frequency list has anything, press delete. I don't want anything after any of the other options. Once X list is in and Y list is in, then I'm going to go down and I'm going to hit the calculate. So I'm going to press enter where it says calculate. Now let's take a look at what that function should have been for us. The function that I've created should be in the form of y equals a times b to the x. For the results of this regression, I should have gotten that a was equal to 1 and b was equal to 3. So that then tells me that my regression equation is 1 times 3 to the x. Now, of course, we all know that 1 times anything is just itself, so this is the regression equation, the very easy regression equation, y equals 3 to the x. On most of the examples that we're working with today, they're not going to be that basic, but I wanted to show you a basic one first of all. If I want to then graph that, I'm going to go to step number 3 here. And for step number 3, I'm going to graph it by putting this equation that I just found into my y1 on my graphing calculator. I can take a clue from my table of values as to how to adjust my window. So I'll hit the window key and make sure that my x's and my y's are appropriate values for the table that I've generated. Now let's go back to page 19, and what we're going to do is do a couple examples together. And I've got some screenshots of my calculator so that you should see what I am seeing on my calculator as well. So looking at the first exercise together, it says the population of Jamestown has been recorded for selected years since the year 2000. That's a really important part of this problem. The table below gives these populations. So you'll notice that we've got a year and we've got a population. All of my years are after the year 2000. Now for the instructions, it says using your calculator, determine a best fit exponential equation. When I see those words, that should tell me, oh, this is when I want to do a regression equation using my graphing calculator. The form of the equation is exponential, so it's y equals a times b to the x. Now, here's something that's really important to note, and you have to really pay attention when you're reading a question. X represents the number of years since 2000. So when I'm entering the data in my graphing calculator in list 1, I can't enter the years 2002, 2004. Instead, I have to enter the values of years since 2000. So 2002, if I subtract 2000, I see that that's 2 years since 2000. 2004 would be 4 years since 2000. 5 years since 2000, 7 years, and 9 years. So those become the numbers that I'm going to enter in list 1. The population is going to go in list 2. Now it's important to note that the reason that I can't put these big values of years 2002, 2004, 2005 in list 1 is because for exponential regressions, these values would not give me an accurate exponential regression. So we'll come back to this question after we enter the information into our graphing calculator. So I'm going to turn the page and go ahead and enter so that you can see what it looks like on my calculator. Now remember that since we already had values in list 1 and list 2, I'm going to have to scroll to the top of both of those lists, press clear and enter so that those values will no longer be there and I can enter this new data. So you'll see that in list 1 I put the years since 2000, and in list 2 I put the populations that I was given for Jamestown. Now I'm going to go to the stat key again on my graphing calculator, and I'm going to again press stat, and then from stat I'm going to arrow over to calculate, and I'm going to go down to 0 where it says exponential regression. Choosing 0, remember that I'm going to have to make sure that for X list I've got L1 filled in, and for Y list I've got L2 filled in, and nothing else is filled in. When I go down to calculate, this is the screen that I got. So I want to take a look at what all of these values mean. First and foremost, they tell me that the form of my equation is going to be of the form y equals a times b to the x. That's really handy that my calculator gives me a template for how to make my equation. Now let's look at the values that I have found. For a, I've got this number, 5,157.920135. For b, 1.0411, etc. So I need to go back to the question and see how I need to round this. So it says that a should be rounded to the nearest integer. So if I'm rounding to the nearest integer, I'm going to say that a is equal to 5,158. I'm always going to write down the correct rounded value that I've been asked for. For b, it says round to the nearest thousandths. So for thousandths, that means I need tenths, hundredths, thousandths. So I need 3 decimal places. So my b value is going to be equal to 1.041, and that's correctly rounded. Now I'm going to go ahead and make my equation. So I'm going to say y is equal to a, 5,158, times b, and I like to put that in parentheses, 1.041 raised to the x. So this is an estimate of an equation. It's a modeled equation for my information, and it tells me how these populations are growing. Now, in the next part of the question, we do see that the population was increasing. So that, of course, tells me that I've got exponential growth. So for this exponential growth, I want to know how much is the population increasing by each year. So remember how we set that up. We say 1 plus r is my b value. So therefore 1 plus r in this problem has to equal 1.041. If I subtract 1 from both sides of the equation, I get that r is equal to 0.041. I, of course, convert that over to a percent, so I'm going to move the decimal point over 2 places to the right and get 4.1% growth each year. And again, it was important to note back when I found my equation that because this b value is bigger than 1, that told me I was going to have exponential growth. Let's continue with exercise number 2, where we again have populations, but this time we've got rabbit populations. Rabbits were accidentally introduced to an island where their population is growing rapidly. Biologists studying the rabbits have periodically recorded their population since they were introduced to the island. Here's the data that they found. This time they're giving us the years since the introduction, so they're not giving us a date, they're giving us how many years. So we are equipped to right away put those numbers into L1. Our population is going to go into L2. So take a minute and maybe pause the video and enter this data into List 1 and List 2, remembering to clear out your lists before you enter this new data. I'm going to go ahead and then press the stat key on my calculator, go over to Calculate, choose option 0, Exponential Regression, and I want to find the exponential regression equation, so I'll go down to Calculate, and I'm going to take a look at the way that I want to round these values. So now looking at my graphing calculator, when I round, I'm seeing that a has to be rounded to the nearest tenth. So for my calculator, and yours should say exactly the same thing, when I rounded the A value, I got 58.2. B has to be rounded to the nearest hundredths, so I got the answer 1.11. If yours doesn't match mine, go back and check your table of values and make sure that you have the correct values in there, and then redo your regression. So here's my equation. I always have to end by giving my equation. 58.2 multiplied by 1.11 raised to the x. And again, you'll notice that I'm always making that equation in exponential form, where I have a value that kind of represents my initial value. It's not quite, because I don't even know how many rabbits were introduced to the population at the beginning. I could use this equation to estimate that. This, of course, is my b value, and because this value is bigger than 1, that's telling me that the number of bunnies on the island has to be growing. Now we'd like to sketch a graph for this, so I would set up a graph on my graphing calculator first and then replicate it on paper. So we're going to go into our y1 and we're going to enter this equation in y1. Now I'm going to go ahead and make a table of values once I enter that in y1. I see that I want to go for 20 years. So on my table of values, I am going to set up, I think I'll do it over here. I don't want to do every year from 0 to 20 because that would be an awful lot of points to graph. So instead, how about if we do every 5 years? So I'm going to make my table so that it counts by 5. Remember, that's in the Table Setup menu. Now when I go back and press Second Table, here are the values that I'm getting. Check your table of values with mine. So I went by 5s on my table. Then I set up my graph so that on the x-axis I'm going by 5s. On the y-axis I'm actually going by 50s, but I only marked every 100. Now, when I'm setting up a window where I'm using values other than 1, I should write down what my window is. So my x's went from 0 to 20 and I counted by 5s. My y's went from 0 to 500 and I counted by 50s. Now, take a minute to go ahead and plot those points. I'm going to do the same. Here's what my graph looked like for my rabbit population. So check yours and see if it matches. It should show an exponential growth. Now for question C, it says, by what percent is the rabbit population growing each year? So again, we're going to take a look at that b value. So in our exponential regression, the b value is 1.11. So b has to stand for 1 plus r. So I'm going to solve for r because that's going to tell me my percent growth. So subtracting 1 from both sides, I get that r is equal to 0.11. Converting that over to a percent, it turns out that the bunnies are increasing by 11% per year on this island. Now the last part of the question says, let's graphically determine to the nearest tenth of a year when the rabbit population will reach 350. So I'm first of all going to show that on my graph that I've drawn here, but then I'm going to go to my graphing calculator. So if the rabbit population has to reach 350, I want to draw a horizontal line on my graph where 350 is. So it looks like this. So that's a population of 350. Now it's best to use my graphing calculator since I want to round this answer to the nearest tenth. I could never read it off of my graph that I've drawn by hand, and in fact mine looks like it might be a little bit inaccurate. So I'm going to go to my graphing calculator, and in Y2 I'm going to enter the number 350 to make that horizontal line. I want to use the Calculate menu, so I'm going to press Second Trace. And under the Calculate menu, I want to find the option that says Intersect. We've done this several times before for other problems. Remember to go to the first function, which in my case is the blue one. Bring the cursor close to the point of intersection and press Enter. Then it says second function, so I'm already at that point of intersection, so I can press enter again. And when it says guess, I'll press enter a third time. My graphing calculator tells me that the x value where they intersect to the nearest tenth is 17.2. You'll notice the y value is 350. So therefore, the answer to this question is it takes 17.2 years for the rabbit population to reach 350. So we are using our graphing calculator to solve for that, but we're going to see in our next unit, in Unit 4, we're going to have a way to algebraically solve for that answer. We've done a lot of great work on our graphing calculator today. Make sure you're very familiar with how to use your calculator to do exponential regressions, because we'll be doing a bunch of those examples tomorrow in class to get some more practice. If you have any questions about your graphing calculator, please be sure to see me. Also, if you've got a calculator that needs charging, make sure it's charged up for class tomorrow. We will see you in class. Have a great night. Bye-bye.